Hello everyone, welcome to another workshop brought to you by Code Labs Academy. Today's workshop is Discover the Machine Learning Landscape. So without overdue, let's start. The objective of our today's workshop is to discover the world of machine learning, its pillars, its some main concepts and definitions, and reveal its horizon and see what's new in this domain. So basically here in this workshop we aim to introduce you to this machine learning field and allow you to maybe pursue this field and or just learn more about it. So the plan of today is we start about with a little introduction. We're gonna talk afterwards about machine learning types, and we're gonna define machine learning, and we're gonna see machine learning types, and we're gonna code also our own self-driving taxi. After that, we are going to see some well-known machine learning frameworks, and finally we're gonna see what's new in machine learning. So let's start from the beginning. So when we talk about machine learning, we are talking about artificial intelligence. So what is actually artificial intelligence? So artificial intelligence is the field that is created as a result of the effort of trying to transfer the natural or human capacities, human intelligence capacities in solving problems to machines, right? So here we are talking about human intelligence. Let's focus on that. So when we talk about intelligence, intelligence has some key elements. For instance, we have a reasoning. So reasoning is the procedure that helps in decision making, prediction, and judgment. We also have learning, which is the ability to develop a skill and acquire the needed knowledge from different kind of sources. Another element of intelligence is perception, and we can see perception as the ability of extracting useful information from the data. And also we have problem solving, which is the process of identifying and understanding a problem in order to propose a solution or different solutions. And finally we have what we call linguistic intelligence, which is the capacity to read, write, understand, and also produce verbal materials and basically establish communication in any kind of any language. So this is the main element of intelligence, and from this artificial intelligence is inspired, and we can see that we have fields inspired from this in artificial intelligence. So we have in AI, we have machine learning, which is the subject of today. We have what we call natural language processing. We have computer vision, cognitive computing, and other fields, of course. But let's just focus on these. So cognitive computing, we can have the best example we can have here is Google Assistant. Here we are trying to optimize, let's say, or achieve the best communication, human-machine interaction and communication. So for computer vision, it's the domain that allows computers to analyze and recognize visual data such as images, videos, etc. And natural language processing enables the machine to process the human speech and language, both speech and language. And finally, of course, we are going to talk about machine learning. So here we have seen a little bit about artificial intelligence, and we have seen that machine learning is a field of AI, and now we're gonna define machine learning and see its types. So machine learning basically is the a number of algorithms and techniques that allows the machine to learn. So we give the machine the ability to learn from experience and data in order to perform some tasks. And the most important thing here is that these algorithms and machines are not being explicitly programmed to do these tasks. So this is the key element here. We don't have a specific or explicit programming to do the task, but we give them the machine the capacity to learn how to do the task. So basically in machine learning we have four main types. So we have supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning, and we are going to see the definition of each type. So again, here we are trying to discover what is this field of machine learning, and we're gonna see what we can do with it. Let's start with the first type of machine learning, which is supervised learning. So basically here we are talking about a type of ML algorithms that use or train or learn on labeled data. So labeled data is when we have a certain amount of data, and for each individual input inside the data we have a label. For instance, if we have an image, we can label it. Does it contain an animal or not? If we have text, we can label it. Is it a positive text or negative text, sentiment wise? So this is examples of labels. So here the models would try to discover the relationships between the input data and the output, and the output here can be the labels. So this is the final goal, is not just discovering the relationship, but using that to predict or compute the labels when we don't have these labels. So we discover how the data work, what is the patterns inside the data, and we discover the relationship between the labels and the pattern between the labels and the data, and this will allow us to predict when we don't have the labels. Again, so here so the supervised learning training is a process that will use labeled data. So we are starting with the training, what we call training that data set, a number of or an amount of data which is labeled, and then this model will be tested on what we call test data set. So the model will see the test data but not see the labels that we have, and then we're gonna use the predicted labels and the actual labels that we have to do some performance measurements. So we will measure the performance of the model during the training, and this will allow us to cycle again and change some parameters. So here this is an important concept where machine learning algorithms or models have parameters that we can change to make the training more efficient and better. So this is the cycle of training a machine learning model in supervised learning: training data set, and then testing, and then performance measurement. And here the performance measurement can depend on the type of the model, of machine learning model, the type of the data, etc. So in supervised learning we have two main tasks. We have classification and we have regression. So basically classification is when we sort input into a given number of categories or classes. So we have the data is labeled, of course we are in supervised learning, and then we're gonna sort the data into groups or categories or classes. So the classification algorithm here can be, for instance, a binary. So we can have binary classification, such as filtering emails to spam or not spam. So we have two classes, so it's binary, either spam or non-spam, and we can categorize customer feedback, for instance, as positive or negative. Another example here, we can have an image given to the model, and then the model will decide if it's a cat picture or a dog picture. So this is an example of binary classification. We can have also what we call feature recognition, such as recognizing handwriting for letters and numbers, and or classifying drugs into many different categories. So it's another classification problem, and this is solved by supervised learning again. So the second task, so we have seen so far that we have AI, and inside the AI we have machine learning, and inside machine learning we have many types. And the first type is supervised learning, and in supervised learning we have seen that we have like two main tasks. First task that we have seen is classification. Now the second task is regression. So basically in regression the model will try to discover a numerical relationship between the input and the output data, and seeing some examples will help us understand better this task. So for instance, if we want to predict real estate prices based on zip code, we are doing a regression. If we are predicting click rates in an online ad, depending on the time of the day. So let's say before noon, afternoon, we have different number of clicks on the online ads, and we are trying to see how the time of the day is influencing the click rates. So we can have a regression that discover the relationship between these two variables or these two pieces of information. So we can also determine how much customers would be willing to pay for a certain product based on their age. Again, this is a typical regression example. We have the age of the customers, and we can try to find a relationship between the age and how they would pay for a certain product. So this was for supervised learning. Now the second type of machine learning is unsupervised learning. So in unsupervised learning, we don't have labels. We work on unlabeled data. So the algorithm here tries to discover the patterns and similarities within the data without trying to rely on some external measurement, for instance labels. So we are focusing on the data and try to discover what's going on inside that data. And also we can have two main tasks in unsupervised learning, such as clustering and associations. So what is clustering? Clustering is trying to discover groups of elements within the data. So as the image here, you can see that the data are pretty much grouped, or the element of the data are grouped in small groups. And so these small groups tend to have the same labels, the same features, and they can be put together. So this is used in recommendation systems and in customer segmentations, etc. We have also associations, the second task, which is basically predicting the rules that describe the data. We use this in dimension reduction, feature selection, etc. So basically, if we want to talk in a little bit of detail about dimension reduction, so basically when we have, let's take an example, when we have a human being represented by the information that describes is human. So the human has, let's say, an ethnicity, a age, a gender, a height, a weight, and etc. And maybe even eye color. So we have so many information, or let's say so many features that can describe one element in our data. So in some cases we can find ourselves that we don't need all of this data, but we can represent faithfully a human being by a lower number of features or less number of features. So this is where we have some feature selection and dimension reduction. So we can represent a human or an element in the data in a lesser dimension than the original one, and this is very important for consuming hardware and computation time, and also efficiency and performance. So now we have seen the supervised and the unsupervised. We have what's in between, which is semi-supervised learning, which has both labeled and unlabeled data. So basically, semi-supervised model will aim to use a small amount of labeled data with a large amount of unlabeled data. So we have both small amount of labeled data and a large amount of unlabeled. So for example, if we want to detect inappropriate messages in a social media stream, we can have a lot of messages. So we have a huge amount of messages, and we can't afford to label them manually. So what we can do is use a semi-supervised technique where we have a small amount of labeled data, and that will help us to have some learning on the larger amount of data. But when we do that, when we use these techniques of semi-supervised learning, we have what we call assumptions. So we have some assumptions on the data. The first one is continuity assumption. So we assume that the data points that we have are close to each other and more likely to have a common label. So this is the first one. We have also the cluster assumption, which is where we are assuming that the data naturally form clusters or groups. So we already have seen this when explaining clustering. So we can have some clusters within the data, and these clusters and group of elements likely share a label and same description. So also we have what we call manifold assumption, which means that we assume that the data roughly lies within a lower dimension, and we have already explained this when we talked about dimension reduction. So basically there is a space where with a lower dimension that describes the data faithfully, and this is the third and last assumption in semi-supervised. So we have seen now three types. We know what is supervised, unsupervised, and also semi-supervised learning, and we are arriving to the last type, which is reinforcement learning. Alright, so reinforcement learning is a way of programming an agent or agents by reward or punishment without needing to specify how the task is to be achieved. So here we have some new concepts. So we have what we call agents, and we have a reward punishment concepts. Let's see an example that will allow us to understand this. So the basic example people use to explain reinforcement learning is when you try to teach your dog to do a trick, or let's say to fetch the ball. So here we are going to throw the ball towards the dog, or so the dog can get it. And in this context, the dog is called an agent. So here I'm gonna call the dog an agent, and this agent is exposed to an environment. This environment can be the house, the garden, etc. Let's continue. So in this environment, in this, let's say, experiment, we have multiple situations where the agent can take different decisions, and we have multiple states. This is what we call states. The environment, we're gonna find ourselves in different states based on different variables. So we have what we call a state, and the dog, which is the agent here, will take actions and move from a state to another state. So here, for instance, if the dog reacts to a specific word like go get the ball, for instance, it will take an action, maybe. So the action can be either getting the ball or not moving or something. So when it takes this action, when it chooses to take an action, we are moving from a state to another state in this environment. So also what we will have is a reward and a penalty in return. So if the dog gets the ball, it will get a reward, or maybe a penalty if it doesn't get the task done. So we have this also concept of reward and penalty. So basically we have an agent that take actions in an environment, and then we can move from a state to another state, or a situation to another situation, and finally we have a reward and a penalty. And the last word that we need to learn is policy, which is basically the strategy that we are choosing to take an action based on a state. So we are trying basically to have a strategy to take the best actions to have the best or the maximum reward. So let's put all of this in one sentence. So the standard model of reinforcement learning includes an agent, the dog for instance, that will interact with an environment through actions, and this will generate new states, and also this environment will respond with a reward, and the reward here is a numerical value that the agent will aim to maximize. So this is resuming the reinforcement learning. Okay, so where do we use this kind of algorithms, this kind of techniques? So reinforcement learning is used in energy systems, so to assess the security of electrical power. It is used in finance, to for stock management and for evaluating business decision. It is also using game solving. As you may already have guessed, it's pretty similar to games where we have a reward system and we have an agent and actions, etc. And it is also used in manufacturing and industry. We have categories of reinforcement learning. We are not going to cover this in details, but just to have an overview. So we have model-based and model-free categories or techniques in reinforcement learning. And in model-free, we're gonna have value-based and policy-based. And here we are gonna see one example of algorithm, which is Q-learning, and we're gonna use it to try to understand more how to implement reinforcement learning. And after that, we're gonna implement it using we're gonna open our Jupyter notebook and we're gonna implement our own self-driving taxi. All right, so let's go. So Q-learning is a non-political reinforcement learning algorithm, which is free model value based, as we saw in the graph before. It seeks actually to find the best action to take given the current state, and it will try to build a table named the Q table. We're gonna see what is that. And so specifically Q-learning will seek to learn a policy that maximizes the total reward. Right, we're gonna dive into details just now. So the Q-learning, when we want to execute this algorithm, this Q-learning, we are going to create what we call a Q table. So the Q table or matrix, it's a matrix that follows the form of state action. So in the lines, in the Q table, in the lines of the Q table, we have what we call states, and in the columns we have the actions. So the states, we have as we saw in the example before, when the ball is inside the garden, for instance, or outside, when you throw the ball outside, we are in one state. And the dog or the agent can take actions depending on the state. So we have multiple actions that the agent can take. And so we form this Q table with the states in the line and the actions in the columns. And we're gonna initialize it with zeros, basically at the beginning, and then we are going to change these values. We're gonna during training, we are going to change the values inside the table. And why we do that? Because the agent will refer to this Q table, and so when it's in this state, for instance, when we are in state 3 to 8, it will try to find what is the best action I can take, seeing this table, to maximize the reward. So it will take a look at these values inside the line and then choose the value that will help him maximize the reward. So this is the goal. The final goal is to get the best reward you can get. All right, so how do we now, let's get back here. So how do we compute these values inside the Q table? How do we change from 0 to these new values that will help us get the best reward? So we will use this formula in here. So this formula will allow us to update the Q table. We are not going to focus a lot on the details of this formula. So basically this formula is based on two parameters. We have gamma and alpha, and this will help us to compute or update the Q value in here. So basically gamma will help us control the importance of the future reward against the immediate one, and alpha is the learning rate. So take a look, Google a bit about learning rate. You'll find that it's a main parameter in supervised learning environment and techniques. And so basically we are going to see how we use this formula, and we're gonna implement all of this. Alright, so now what is the actual process and algorithm? So we're gonna start with initializing the Q table with zeros. The Q table is when we have the lines is the states or the situations the agent can encounter, and in the columns we have the actions that the agent can take. We're gonna observe the state that we are in, and we're gonna then pick an action. Picking an action, we're gonna do that by trying to have the maximum reward or to get the maximum value, or we can start with random values. And then after that, if we choose a reward, we can choose an action. We're gonna get a reward R, and we are moving to a new state because we have taken an action. And this will be fed to the formula that we just saw that will be used to update the queue table. And so this is the process. We're gonna see a state, pick an action based on the maximum value, and then we're gonna have a new reward and move into a new state, and we're gonna try to update the table using the formula that we have seen before. Okay, so now let's code all of this and let's build our own self-driving taxi. So here we have we're gonna build our self-driving cab or self-driving taxi, and our self-driving cab should be able to drop off the passengers to the right location. It should save the passengers time by taking the minimum time possible to drop off. Also, it should take care of the passenger safety, so it should respect traffic rules. So we have a set of rules that we need our self-driving car to follow. All right, and so to do that, we are going to use OpenAI Gym. So OpenAI is an artificial intelligence research organization, and they give us the tool OpenAI Gym that will help us develop and compare reinforcement learning algorithms. We're gonna use that today. So to implement the Q-learning that we just saw, so what we have described in the slides, we need to go through the concept of reinforcement learning to better understand what we are doing. So here we're gonna talk first about the reward. So here our agent in this case is the imaginary driver or the self-driving taxi. So to give the reward to the agent should receive a high positive reward if he successfully drop off. For each successful drop off, we're gonna give a positive high reward because this is the behavior that we want. And also, if the agent should be penalized if it tries to drop off a passenger in a wrong location. Also, the agent should get a slightly negative reward when not making to the destination in every time step. So this is basically we are trying to tell the agent or to teach the agent that it's important to get in time, but it's not more important than the other rules. This is why we give a slight negative reward. And the other rules that are more important is to drop off the passenger at the right location and to respect the rules, the traffic rules. So we don't want it to have a big negative reward, so it will break the rules and not respect them, just respect time. So this is important also. So this is for the reward, and for the state space, or what we have as states. A state again is the different situation that we have in our environment. All right, let's describe our environment then. So in our environment, you can see here we have a parking lot with a grid of five lines and 5 columns. So we have 25 positions that the car can be in when moving. And you can see that the car can move either north, east, west, or south. And we also can pick up a passenger or drop off a passenger in one of 4 positions. So we only have 4 positions to pick up a passenger or drop him, her off. So here we have R, G, and B and Y. This is the 4 locations where we are going to either pick up or drop off of the passenger. All right, so this is our environment quickly. So here, if we want to go into details here, what we want to do now, what we want to do is to know what are the possible situations and states that we can encounter. So basically, since we have said that we have 5 times 5 position that the taxi can be in, we already have 5 times 5 situation, let's say, and then we can have 4 destination. All right, we can have when the passenger is asking for a taxi, it can go to Y, B, G, and R. So we have 4 possible destination in this environment. So when we are describing this universe or this environment that we have only a parking lot, a passenger, and a taxi, we can have these possibilities. We can have 25 position where we can find the cab, and we're gonna have 4 destinations. So this is why we have another 4 here. So we have 5 times 5 for the position of the cab, times 4 for the destination that we currently have. So this is basic probability, and we have this also this 5. So what is exactly this 5? This 5 will describe the position of the passenger. So the passenger can be either in one of the 4 positions, Y, B, again, G, or R, for pickup or drop off. So it can be in either one of these 4, and there is one additional position that the passenger can be in, which is inside the taxi. So the passenger can be either inside the taxi or one of these 4. All right, so this is why we have this 5. So why we are doing this again, we are trying to find every possible situation that can be in our environment. This is why we are trying to calculate the probabilities here, or the possibilities here. So we have 5 times 5 for each position of the taxi, and for each position we can have 4 destinations. So this is why for each one of the 5 times 5 we have 4 possibilities. And then for the 5 times 5 times 4, we can also have the passenger inside the taxi or one of the 4 positions. So this is why in each one of these possibilities we're gonna have 5 more. So this is why we have the final 5 times 5 times 5 times 4, which is 500 total possible states in our environment. All right. Okay, so moving on. We have the action space, or the possible actions that the agent can take. So as we already said, the taxi can move south, north, east, west. It can also pick up a person or drop off a person. So we have 6. We have 6 actions. All right. So let's go now to the implementation. We're gonna see some Python code. We need to install these libraries. I already did that. Gonna import here libraries. So the environment here, we're gonna use Gym again to build this environment as what we have already described. We're gonna use the taxi v3 environment, and you can see here that it creates. This is like capturing the environment. We can see that we have the 4 positions, and we have this is the taxi where it is initially. And we can see that we have an action space of 6. So this is the number of actions that the agent can take, and the number of states. We have 500 states. All right. Okay. We can also choose to play around with the states. You can see these details later. We can like specify, encode a state. You have here, for instance, the taxi row, the taxi column, passenger index, etc., etc. So let's focus more on the agent training. So basically here, this piece of code will take this is the implementation of the Q-learning. So the formula that we have seen before, we are going to do the cycle also that we have seen before, where we are going to choose an action and then try to update the Q table based on the formula. All right. So if we can start the training in here. All right. So now with the values of the hyperparameters alpha, gamma, and epsilon, we are trying to now train the agents to take actions, and the agent will take rewards and penalties based on the actions that it will take, and we are going to see the result in a few. So here I need also to explain to you what is an episode in reinforcement learning. So an episode is basically when we start from taking an action from a certain state, and then we're gonna take actions, a number of actions, and then we're gonna arrive to a terminal state. So what is a terminal state? A terminal state is basically when we arrive into a situation that it's done. We can't do anything more. So for instance, if the taxi hit the wall, or if the taxi drop off the passenger, so it's the end of our episode, and we are going to move to another episode and try the learning again and again until the agent will learn what it should do, what it shouldn't do. Alright, so it will take some time, and this is now the agent is training using the Q learning. So this is inspired by a blog that I found really interesting. I will drop the link also for reference in the comments, and you can check that. Alright, it's almost done. Just a few seconds. So here the number of episodes, we can change this inside this loop, so we can choose how many episodes we wish to have. So there is no rule here. Also, we can like try multiple values and see what's the best. So here the training is finished. Let's take a look. How is the agent doing now? So what we are seeing now, we are seeing that the taxi is starting from a position, picking up a person from B and dropping off in Y. Let's take a look again. So you can see that here the cab is respecting, after the training, the cab is respecting the rules. It's not going like hitting the walls. It's moving in the shortest path to go from B to Y. Let's see it again from a starting position. So this shows how the agent has trained, and what are the actions that it takes when it encounters a situation. And here you can see the final action, which is drop off. Alright, so here basically you can run this cell, and you have an evaluation, general evaluation of the performance. You can have the average timestamp per episode, so how much time did it take to arrive, and how much penalty per episode. So basically here, after enough training, you can see that you don't have any penalty, you only have rewards. Alright, okay, let's get back now to our presentation. We have a few more steps to go through. So we have seen the different types of machine learning, and we have implemented the code and encoded our own self-driving taxi using reinforcement learning. Hopefully this helped you get to understand better RL and ML in general. So let's continue with machine learning frameworks. So here this is not all, but some of the most known machine learning frameworks. So we have some training frameworks, and we have deployment frameworks. And so we have, for instance, PyTorch and FastAI. FastAI is built on top of PyTorch. PyTorch is like really efficient and used by a lot of people when implementing neural networks, etc., and machine learning models. And we have also TensorFlow, which is well known. and maybe it's the most popular framework for deep learning and building machine learning models. And we have also it's called MXNet. And for deployment, we have TensorFlow Lite for deploying on mobile. We have ML Core for basically deploying machine learning on the iOS systems, and TensorRT when we want to deploy on GPUs. And so while you have this distinction between training and deployment, this is basically when we are training a model, we are doing some operations that we don't need during deployment. For instance, if we are doing some prediction, we are going to train our model, so we have more operations to do during the training that we don't need when we are deploying the model. So when we are deploying the model, we just want to predict and not train. And these frameworks are optimized for deployment, and these are optimized for training. So this is why basically we have this distinction. And we have also ONNX framework. So this framework helps to move from one framework to another, so basically it supports a lot of versions, and it's really useful in these situations when you are trying to move from one framework to another. So basically this is just to give you a rough sense on what's happening, what's going on, and if you want to choose like a framework, it usually depends on what framework are you familiar with, and also sometimes what do you want to do exactly. So let's finish with our last section, where it's what's new in machine learning, and we are going to talk about the new models in machine learning and what people are doing at the top level. And so here we are going to talk about language models. So language models, simplified, it's probabilistic statistical methods that will give or assign probabilities to words. So we have a sequence of words, a text, and we're going to assign probabilities to these words. So here we have some of the largest language models. We are going to see the first one, PaLM. So PaLM, or pathway language, is a model that has 540 billion parameter. It's a really large model, and it uses the pathway system. So the pathway system is introduced by Google, and here we want a model to be more generalized. We don't want it to do one task, but we want to do multiple tasks with high performance, of course. So we can see here in this figure from Google, from the source here, that by increasing the number of parameters, we are able to do more and more tasks with the model. So it goes from language understanding, summarization, to arithmetic, code compilation, question answering, etc., etc. Even joke explanation. So this model can explain jokes also. So let's see an example. So here in this example, this model PaLM can answer questions like humans do. So here, for instance, if we give this example to a model, and we want this example output, the model can do that using like a chain of thoughts prompting. So basically, what is it? So here the prompt is: the cafeteria had 23 apples, we used 20, and then we bought 6, and so how many apples do I have? So the model will take step by step, decomposing the problem and solving it. So this is the answer of the model. So basically we have the cafeteria has 23 apples originally, and then they used 20, so I have 23 minus 20 equals to 3. So we have a first step, and then we bought 6, so we have 3 plus 6, and we have 9, which is the correct answer. So the model can give such answers, PaLM model. It can also understand the description of a problem and generate the code for that, and code in Python, for instance. It can also, like here, read this description, get the variables, and get the formula, and return you the result. So it writes the program. It can also translate from one language to another. For instance, here from C to Python. This is written in C, it will write it in Python. So it can do a lot of stuff. Second type of machine learning models are going to see is, we have seen language models. Now we're gonna see text to image generation. So text to image generation is when we give a caption or text and we generate images from that. You can example of this kind of models, we have DALL-E 2 and Imagine, and we have more. So without overdue, let's see what these kind of models can do. So we give a caption to a model, and the model will say that, for instance, here we have like a penguin reading a book peacefully while having coffee in the morning. So this is a caption given to the model. So the model now will take a look at this, and it will try to draw or generate an image that faithfully represent this caption. So take a few seconds, just try to imagine the image that correspond to this caption. Alright, this is the result of the model. This is an image generated by the model where we have a penguin reading a book peacefully while having coffee in the morning. Let's see another example. We can have, for instance, this caption: a painting of a fox sitting in a field at sunrise in the style of Claude Monet, a painter, famous painter. And again, take a few seconds, try to see or imagine what the model can give. And this is the result of the model. So you can see that it's really amazing. So just from the caption, the model can generate such images in respect to style also. So it understands deeply the sentence or the meaning behind it. For instance, the model DALL-E 2 can generate variations of one image. So for instance, if we give it this image, this model can give us variations that doesn't exist, that will be generated by the model. So this is the original image, and this is the variations based on the first image or the source image. Can you see here? So let's get back. This is again the original image, and now we have the generated image. You can see that it changed, like the windows, the angle, the plants, the colors, etc. Inspired from the first one. Right, so let's take another example. So we have a more complex sentence. Here we have an art gallery displaying Monet paintings. The art gallery is loaded. Robots are going around at the art gallery using paddle boards. Right, so you can go crazy. And let's see how the models do. So this is the caption, and this is the result from Imagine, from Google. We have this image, and this is from DALL-E 2. So we can see that even though if we go crazy with the caption, it still gives us a response. Alright. Well, we arrive at the end of this workshop. Hopefully you learned a bit about machine learning and discovered this interesting field. And so why do we have this workshop? So this workshop is again brought to you by Codlabs Academy, and we like to share what we know, and we have a highly interactive learning platform, and we provide one-to-one career coaching, and we have multiple topics, so data science, web development, cybersecurity, and more. And we have a lot of these free workshops to introduce people to new concepts. And basically, if you have any question, feel free to write them in the comments or to contact us. You can contact me via email. There is my email. You can visit our website for more information, and hopefully again you have learned something today. Thank you for watching till the end, and see you soon.